Okay guys, welcome back. So another video in this series where I'm using RStudio to conduct data science tasks, create data visualizations and run data analysis. So I'm trying to keep on a roll with these videos. This is video number 17. And in order to do that, just to keep creating week on week and putting them out, I'm going to keep them quite basic and as short as I possibly can. So at the moment, a couple of videos ago, I started covering data visualizations. So we looked at scatter plots, histograms. This week I'm going to look at boxplots, how to create boxplots using ggplot. So boxplots are useful and probably the most common way you see data being visualized, where you have the distribution of scores on a numeric variable and then those scores broken down by groups on some other categorical variable. So you've got one categorical variable, a variable with a number of categories, male, female, for example, and you're looking at their scores on another variable that's a scale variable, a numeric variable. So these are often presented side by side. That you can see the distribution of the scores presented side by side. And what the box plot gives you is some quite useful information for comparing the groups. So you can see the median value, the 50th percentile, that would be something called the interquartile range, or the IQR, which extends from the 25th percentile to the 75th percentile of scores for that particular group. And then you've usually got these little whiskers that extend about 1.5 times the interquartile range beyond the interquartile range to kind of the furthest non-outlier data point. And then you might also have indicated any outliers just as individual points beyond those whiskers. Okay, so they're useful because the shape and whiskers provide, the shape of the box and the whiskers provide an indication of how symmetric or skewed the data is. I'm going to use ggplot. I'm going to use a built-in data set again. I'm going to use the tidyverse and I'm going to use the penguins data set, and I'll probably also use the mammal sleep data set, which I've used in previous examples. But the grammar for creating box plots using ggplot follows that usual structure that I've mentioned in previous videos, where we have to specify what the data is we want to use. We have to specify the mapping, what we want to map in terms of the aesthetics, which variables we want to use, and then how we want them to be plotted. We have to specify the geometry, essentially the shapes, the type of geometry we want to use. So for a box plot, quite straightforward really. The geometry that's needed is geom_boxplot. Okay, so we'll see that in a second. But first of all, I'm going to load up the tidyverse, which is obviously, I keep saying this in every video, I think. It's that umbrella package in R, which contains a number of packages that are useful for tidying data and visualizing data, including ggplot. Okay, so I've just done Control and Enter, and I've run that library tidyverse command. You can see it printed in the console below in the bottom left. And you can see now that it's running and it's executing. So it's showing you the different dplyr, forecast, ggplot, the different packages, some of the packages that it's loading. And as usual, we get that conflicts message telling us where we've got method calls or function calls that have the same name across different packages. So we have to be careful when we're specifying which package we want to use. Okay, but it's returned my command. If you look there, if I put my cursor there, it's returned my command line to me, so we know that's loaded up the tidyverse for us. The other thing I'm going to load from the library is the Palmer Penguins package, which has got that penguins data set. So I use that for the first one. Just create a really simple box plot. So that's worked. It's returned the command line to us on the console below. So I'm just going to create a box plot. I'm going to plot the 3 penguin species as separate groups, separate categories, and their body mass by species, essentially. So the boxes will show us the distribution of body mass for the 3 different species. To do that, I'm going to I'm not saving this as a separate object, such as boxplot1 or anything like that, and assigning it. I'm not creating any new variables in this environment. I'm just going to keep it real simple. Just create the plot, essentially. So I'm calling ggplot, and then in parentheses I'm passing the first argument being the data that I want to use. It's penguins. I could have done this as you've seen me do previously. I could have got data equals penguins, but you don't need to do that. You can. So I'm kind of, as we've gone on, I'm kind of tidying up the syntax and making it. I'm making my arguments less explicit, but making the code more streamlined, so to speak. Then I've got a comma, and then I've got AES. So I could have specified here mapping equals AES for aesthetics, but I've not done that. I've just put AES. And then I need to specify what I want on the X and Y axis. So I've got species on the X axis, so it's going to give us our 3 species as categories on the X axis. And then body mass in grams will specify it on the Y axis. And then after that, I've got that plus, and I've got my geom box plot with parentheses. So if I highlight that, that's the command, and if I do Control and Enter to run it, it should work, and we should get a plot. Here we go. Yeah, so in our plots tab, that's popped up. So I've not done any kind of nice tidying and labeling or anything like that. So then the axis labels like body underscore mass underscore G is presented exactly as it's shown in the data frame. So we could tidy that up, but in this case we won't. I just wanted to demonstrate what it's like. So you can see there it's created a box plot for us. Species, 3 species, Adelie, Chimstrap and Gentoo are 3 penguin species. And then you can see the body mass, obviously Gentoo, much on the whole, much larger penguin, much higher body mass. And you can see the black line in the middle here, this is the median value, the 50th percentile of scores. The bottom of the box here and the top of the box here represent the 25th and 75th percentile. So from here to here is our interquartile range. And then we've got our whiskers going beyond the box. So this whisker is 1.5 times the interquartile range. So it pretty much takes us to the kind of furthest non-outlier data point. And then if there are any data points beyond that, these are often presented as just individual data points. So you could see here, there may be one, hopefully they're not stacked on top of each other. But if you look at Chinstrap, you've got a data point here and one here. So we've got a couple of outliers. One penguin that's kind of extremely large for a Chinstrap penguin, and one that seems to be very small in terms of its body mass for a Chinstrap penguin. So that's a box plot essentially, quite useful for looking at the distribution of scores. And you can see kind of the wider the distribution here, you can see here Chinstrap, which most 50% of the scores are quite tightly clustered between what we say 3,500 and 4,000 grams. Some of the others though much broader range. Okay, so that's it. That's essentially a box plot. Let's play around with it a little bit and look at a couple of others though. So on this occasion, I kind of just used the real basic syntax for ggplot for this first plot. But what I will do is demonstrate a similar sort of thing, but this time I'll use the mammal sleep data again. I think I used this for maybe a bar chart or a histogram, something like that, one of the previous plots. But so this is the mammal sleep data. It's a built-in data set for the tidyverse. And if I do that view msleep, the name of the data set, you can see it presents as a nice pop-up window here, and we can see different variables, numeric variables, categorical variables. So what I'll do this time is I'll kind of create a box plot, but I'll use the pipe operator to pipe in one argument as the input for the next argument, essentially. So you guys have seen this before, hopefully. This is kind of the tidyverse version. It's not the native pipe operator used in R, but if you do, you can type that % greater than % if you want, but you can also do Control Shift and M, and it will create that character string for you, essentially, I suppose is a way to describe it. So what I'm doing here is, if we look from lines 31 to 34, I'll highlight it, taking the msleep data, and then I'm piping that in as input into the next line. What I'm going to do is I'm going to use this vor, and we know from previous videos there's kind of like omnivore, carnivore, herbivore, and there's some missing data, so there was like an NA category. So I'm going to drop the missing data So we've not got an extra category that represents animals where this wasn't recorded, what type of diet they eat. So I'm using drop NA and I'm specifying vor. So I'm saying take the msleep data and then, which is a kind of in words how you could describe that pipe operator, drop the missing values from the vor variable, that categorical variable, and then use ggplot to plot vor on the x-axis against total sleep on the y-axis. And then I'm saying the geometry I want you to use for this is the box plot. And ggplot is going to know in the background, it's going to know that vor is a categorical variable. So a box plot is appropriate. So there we go. If I run that, use Control and Enter to run that, you can see we've got another box plot here which shows kind of Carni, Herbie, Insecti, Omni. So insectivore is quite a wide interquartile range and very short whiskers on that one. Omnivores as well. Not a huge spread of scores here, but you can see we've got loads of outliers. So you can see the extent to which the more symmetric these boxes are, with the whiskers and the median in the middle, say, the more normally distributed we'd assume that they are, and less skewed. So these are quite skewed. This is very skewed, and this in particular insectivores is highly skewed. Okay, so a couple of little extra things. I'm not going to play around with the color or do any kind of fancy styling. It's easy enough to look that sort of stuff up on the documentation for ggplot if you want to do that. But I'll demonstrate a couple of things. And sometimes you see box plots created where by default I usually create them so we've got the categorical variable on the x-axis as this is, and the numeric variable on the y-axis. But sometimes people do it the other way around, where they put the categories on the y-axis and the numeric variable on the x-axis. So to do that, we can just flip this around. So we can do that, and all we've got to do is add this coord flip argument here. So taking exactly the same plot, but if we do coord flip, you'll see what that means, and that kind of presents it sort of sideways on. Personally, I don't really care for that too much. It doesn't matter. I don't think really. So maybe if you go to publish research, you've got a box plot, maybe they've got specific rules about how you've got to present them and things like that. One thing I would say though is the times when that is useful is if you've got categories, a categorical variable where that you've got a lot of categories and they've got quite large labels. Okay, so let me demonstrate that. So I'm going to do the same thing. I'm going to take the msleep data and then I'm going to create a box plot. But this time, rather than using that vor categorical variable, which only got 4 variables, I'm going to use order. So the order is kind of like are they a cat? Are they a primate? That type of thing. So there's loads more. So you probably won't want to plot this as a box plot, really. It's kind of going to get a bit busy and messy, but it will highlight the point I'm trying to make. So if you go, if I run this, do Control and Enter, you see we've got like 1, 2, 3, 4, 5, 6, about 12 to 15 orders of mammal there, so to speak. So it's really busy. But the thing that looks terrible about it is, if you look at the labels for the different categories on the x-axis, they just overlap. They're all running into each other. They're overlapping. It's kind of like almost a useless plot, really. But if we did the coordinate flip on it, that would help us to solve that problem a little bit. There are going to be other ways to do it where you can kind of jitter it up on a certain angle and things like that, which kind of more advanced things for styling we can play around with. But if I run this again, but we coord flip it, there you go. You can see that looks much tidier. So you can actually read the names of the orders, and you can see the bars and the distribution of scores. Obviously, I mean, this is kind of an extreme case. I don't think anyone would really want to create a box plot with that many categories to compare, because it looks far too messy and busy. But you can see there, like it's not totally uninformative. You can see there, like carnivores got quite a widespread of sleep there, quite a large distribution of hours that they spend sleeping, and rodents do as well. Some of the others less so. Primates kind of less so. Primates all seems to be between about 6 and 11 hours. This extreme outlier on primates there, that might be kind of humans maybe on the weekend. But okay, so that's it. That's all I'm going to demonstrate in this particular video. That was just kind of how to create box plots in R. I wanted to keep it basic and not go into loads of styling and colouring and things like that and changing the background, just to keep the video short. So I've got time to keep recording them, keep publishing them on my YouTube channel. Hopefully this was useful, and thanks for listening and watching, and I'll record another one soon. So I think next up what I will record is I'll record a short video on how to create violin plots, which are similar to box plots, but are kind of much more useful to actually understand how the scores are distributed. The fact that we just use a box with a box plot, like a rectangular shape, kind of hides a lot of information about where the scores, where you've got more scores and where you've got less. Okay, thanks guys, and I will speak to you soon.